Good morning. Today we're going to graph a function, and it's going to be a rational function, and it's f of x equals x plus 3 over x plus 2. We're going to use limits to find out where the horizontal asymptotes as well as the vertical asymptotes, if any. And we're also going to use the x and y intercepts as points of interest to help us graph the function. So first, I'm going to look at the y-intercept. So that's f of 0, and f of 0 equals 3/2. So we can say that the y-intercept is the point 0, 3/2, 1.5 if you will. So we'll go ahead and we will make that noted on the graph about right there in red. I'll make a little point there in red so that we know. The next point of interest would be the x-intercept. And the x-intercept is going to be where f of x equals 0. And that's where the numerator, of course, is equal to 0. So that implies that x equals -3. So the x-intercept, and there's only one in this case, is going to be -3, 0. So we'll put that on the graph, and I'll make it in blue. So that's going to be at -3, 0, 1, 2, 3. It's going to be about right there, and I'll make a little mark right there in blue. So now we want to look at vertical asymptotes, or where the function is undefined. Well, actually discontinuities, where the function is undefined. Kind of gave it away, but anyway. So we want to know where f of x does not exist, is undefined, and that implies that x equals -2, of course. So we have a vertical asymptote at x equals -2. And I will draw that on the graph. I think I'm going to put that in red. And if you'll bear with me a second. So here we'll line up the square, and I will x equals -2, so I'll make this dashed line to signify a vertical asymptote. I'll extend, ooh, didn't come out, did it? Make it a little bit better. There we go. We have a vertical asymptote at x equals -2. And now we're going to look at the limit as x approaches -2 from the left of f of x, x plus 3 over x plus 2. And that's going to tell us in what direction is it going to positive or negative infinity as it comes from the left side of -2 to that vertical asymptote. Well, we have the form. We're going to have 1 over 0, and as we approach -2 from the left, the denominator is going to have negative values, so that equals -infinity. So just use green, or why not purple? Use some purple right here to say, just to kind of make a note that our graph goes down into -infinity at that point. So now we'll look the limit as x approaches -2 from the right of x plus 3 over x plus 2. That equals 1 over 0, but this time as x approaches 2 from the right, it's approaching 0 through positive values, so we say that that's positive infinity. So therefore, we know as we approach -2, the vertical asymptote from the right the graph is going in a positive infinite direction. So now we're going to look for horizontal asymptotes. It's about the last thing it is the last thing we're going to do. So we're going to take the limit as x approaches negative infinity of x plus 3 over x plus 2. And since this is a rational function, it's a ratio of two polynomial functions, the degree of the numerator is the same as the degree of the denominator. So we say as x goes to negative infinity, it will be the ratio of the leading coefficients, which is of course 1. So we know that it's approaching the line. And we'll draw that in there. Now I think we'll do it in purple. At y equals 1 is our horizontal asymptote, at least in one direction. And oops, let me get my head in front of there. Just get it on the other side. And so we have our horizontal asymptote, at least in one direction, but we're fixing to find out that it goes in the other direction too. So we'll take the limit as x approaches positive infinity of x plus 3 over x plus 2. Again, it's a rational function. The degree of the numerator is the same as the degree of the denominator, so it goes to 1. Both of these things imply that y equals 1 is a horizontal asymptote of f. So now it's time to put the pieces together. So we know that as x approaches negative infinity, it approaches the y value negative 1. We know that it comes down, crosses the x-axis, and as it approaches negative 2, we go to negative infinity. We know on the other side of negative 2, we're coming down from positive infinity. We cross the y-axis at 0, 3/2, and then as we go to positive infinity, we approach, again, the horizontal asymptote, y equals 1. And so this is a very simple, what we call function summary. It doesn't include derivatives. It's just using x and y intercepts and vertical asymptotes and horizontal asymptotes, and using the limit process in order to prove them. So that's about it. Thanks.